Hello everyone, welcome to Practical Mechanics. I'm Mohsen. Today's videos we want to talk about area moment of inertia I and polar moment of inertia J. In deriving the formula for bending stress in previous video, we arrive at mathematical expression which was y squared delta A which is called the second moment of a small tiny area. Let's calculate this value for a cross sections because this is the moment of inertia for a cross section, which for example is rectangular shape. Assume that we have coordinate axes, 0 at the centroid of the cross sections, and then is started as minus h2 to plus h2, and the width is equal to b minus b2 to b2, or we can say the area is equal to b times h. Width is b and the height is h. Then this summation is for an increment of the area. Assume this is our delta A, and this is delta y, and this distance to centroid is y. Then the area here is delta y times b, delta A, b times width times height, delta y. If we make them very smaller, very tiny, delta y change to very close to 0, but not 0, is we call it dy, and write it in instead of a summation, write it integration form. Then we have y to dA, and integration is taken from minus h over 2 to h over 2. What is it? Minus h over 2, and is equal to y2 squared times dA. The area is when delta y approaches very, very small, that we call it dy. Then delta area is very, very tiny strip here, which is called dy times b, small tiny area, y b times dy. Then integration, b is a constant. We can take it out of the integral. And you know the integration of y squared dy is equal to 1/3 of y cubed, and the value from h over 2 to h plus 2, and then e over 3 times h over 2, 3, minus h over 2 cubed, and is equal to 1/3 of b times h cubed over 8 plus h cubed over 8. Minus cube is minus, times minus is plus. Then This is equal to h cube over 4. B3 times h cube over 4 is 112 bh cube. You know this moment of inertia of the rectangular cross section about its centroidal axis or the neutral axis in the beam, which is 1 over 12 bh cube. If you want to find out this moment of inertia about any other axis, why we need that? In composite cross sections, assume that we have a T-beam and the centroid of the composite area is here, around this axis. And you want to find out the moment of inertia of these cross sections. Then you must find first moment of inertia of these two simple geometric shapes, one rectangular top, we called it A1, one rectangular bottom, or web of the beam, flange of the beam. This is A2. Then the method is to find moment of inertia of each one, and then transfer that moment of inertia from its own axis, centroidal axis, to the neutral axis of the beam. It means that each part here, we divide this cross section into two simple geometric shape, one here and another one is here. First, we calculated about this axis and then transfer from this axis to here. Assume that this is, for example, this is a thickness and this is depth of web of the beam edge, and this is, for example, you can say H2, and this is E. Then moment of inertia of the top rectangle is I1 around its centroidal axis. We show it I1 bar is equal to 112 that we calculated here of the H2 cube. And for this one, around this neutral axis, I bar 2 for this web of the beam is equal to 1 over 12 for any rectangular shape times B, which is T here, thickness, H to power 3. Then we calculated a simple geometric shape, moment inertia about its own axis. And then we want to use parallel axis theorem to transfer all this moment of inertia around the neutral axis of the beam, which is this axis. Then I, about the centroidal axis of the beam, is equal to I1 or plus A1 D1 to power 2. This is the principle of transfer. And this is called D1, distance between centroid of this part with respect to neutral axis. And we call this distance D2. Then plus I bar 2 plus A2 D2 to power 2. Okay? We can call it I is equal to I1. We mean by I1, we mean the moment of inertia of this area around the neutral axis of the beam, I bar, plus I2 means the moment of inertia of this simple shape around this axis, neutral axis of the beam. Okay. When you add them together, you can add them. Then you can go and A1 is equal to B times H2, and I2 is equal to T times H. and you must have these distances as well. This is how to calculate moment of inertia of the cross section of a beam, that you need that for formula to calculate bending stress in the beams. Thank you for watching. See you in the next video.